Black holes have long captivated both scientists and the general public, standing as some of the most enigmatic and extreme entities in the cosmos. They push the boundaries of our understanding of physics and the very fabric of space-time. Among the countless questions they inspire, one particularly thought-provoking inquiry emerges: how deep is a black hole? At first glance, this question makes perfect sense from a human perspective. We often compare the unknown to something familiar, like a well, where we instinctively peer over the edge and wonder how far down it goes. But black holes defy such comparisons. They are not physical structures with a bottom or a measurable depth. Instead, they exist as distortions in spacetime, where conventional ideas of depth, surface, and even the passage of time cease to function as we know them. If you were standing by a well and wanted to measure its depth, you might drop a stone and listen for a splash. By timing how long it takes for the stone to hit the bottom, you could use a simple physics formula to calculate the depth. This works because gravity accelerates objects at a known rate on Earth, allowing us to make precise measurements. But a black hole operates under entirely different principles. There is no bottom to reach, no surface to land on, and no way for light, or anything else, to escape once it crosses a critical boundary known as the event horizon. Unlike a well or a planet, which has a physical surface, a black hole is a region of spacetime where gravity is so intense that nothing, not even light, can escape its pull. To understand why we can't measure the depth of a black hole in the traditional sense, we need to consider the way it bends space and time. When we observe an object falling toward a black hole from the outside, we never actually see it cross the event horizon. Instead, due to the extreme gravitational field, time for the falling object appears to slow down infinitely from an external observer's perspective. This means that, from our point of view, anything that falls into a black hole seems to be frozen in time at the event horizon, never actually disappearing. But from the perspective of the falling object, it would cross the event horizon and continue inward, potentially toward the singularity, a point where all known laws of physics break down. This leads to an extraordinary conclusion: a black hole, in a way, exists in an infinite future relative to us. The gravitational pull is so extreme that light attempting to leave the event horizon is infinitely redshifted, meaning it loses all its energy and never escapes. Because of this, we cannot measure a depth. It is a concept that simply does not apply in the way we typically understand it. While we can't determine how deep a black hole is, we can measure its distance from Earth. For example, the supermassive black hole at the center of our Milky Way, known as Sagittarius A, is located about 26,000 light-years away. This means that the light we see from the region surrounding the black hole took 26,000 years to reach us. Similarly, we can estimate the size of the event horizon, which depends on the mass of the black hole. For Sagittarius A, the event horizon has a diameter of approximately 24 million kilometers, or 15 million miles. However, this does not mean there is a bottom to reach. It simply marks the boundary beyond which no information can escape. So, to answer the question, how deep is a black hole? The best response is that a black hole is infinitely deep, not in the sense that it has a bottomless pit, but because it exists in a realm where space and time are so distorted that concepts like depth become meaningless. This question reminds us of how black holes challenge our intuitive understanding of the universe. They force us to think beyond everyday physics and into the realm of relativity, quantum mechanics, and the very fabric of space-time. Black holes may be beyond our reach physically, but through curiosity and science, we can still uncover their deepest secrets. Thanks for watching. If you enjoyed the video, give us a like, comment, and subscribe. And don't forget to click the bell icon to stay updated on the latest space discoveries.